Hello and welcome to HopHacks Tech Demos Spring 2016. We're gonna go check out. Fucking guy, we have to throw it away now. We can't use that. We're gonna go check out some of the rooms and some of the tech demos. Come on. This way. Go over here. Right this way. Just come in through here. Watch the door. Hey guys. You guys ready to present? Could we talk to you guys? Awesome. Cool. So can you guys introduce yourselves, talk a little bit about your hacks? I'm Jordan, and this is the camera. There's a person behind it, but just it's okay. This is super low pressure. We're just going to publish this everywhere. Yeah, a minute. Cool. So, hi, Jordan. Hey, I'm Jordan.
I'm Chad.
Cool. So, can you just talk a little bit about your app? Show us some cool stuff happening.
So our app is basically the presentation professional training tool for presentation. So people who want to practice presentation, they can practice at your home and then still feel like they are presenting in front of the large audience. The way we do it is like we incorporate Oculus Rift virtual reality, and it draws you into the real classroom environments, and then at the same time while you're presenting. You have an option to record yourself, so you can watch this video later and then give yourself some feedback or see what you're doing wrong. And also we time your presentation for each slide, so that means let's say if your overall presentation is supposed to be 10 minutes, you can then figure out the time frame or where you should say less, where you should say more. We give this kind of feedback, so we can show demonstration.
This is recording going on right now, and you can see your presentation right along with the 3D space. So this is your presentation along with the 3D space. We use that, we use the PowerPoint to present it right here, and after your first recording is finished, it's published, and you can go on to record second recording, and it changes the PowerPoint as well along with the recording. And you are recording one video for every slide, so you can look back at any slide and review yourself.
So technically you are uploading your already had prepared presentation like PowerPoint, and then we convert that into images, and then we stitch that into virtual reality world, so you can see your slides while you're inside the virtual reality.
Right, that's really awesome, you guys. Looking forward to getting some judges around here and seeing what they think. Thank you so much. Let's see. Yeah. Hey guys, you have a few minutes to talk to us a bit about what you've been working on. Very cool. So awesome. Just give us super fast pitch what you're working on. Give us an intro about you guys and your tech stack, stuff like that.
Sure. Yeah, hey, so I'm Vuk Petrovic. I go to Temple University, and my team is also from Temple University.
Hi, my name is Chechen. I also Temple University, computer science major.
Computer science major.
I'm Shale, and I'm an electrical engineering major.
So anyway, what we worked on was Alexa Plays. Basically, it's a way of playing an RPG video game using nothing but voice input. And we think this game is unique in the sense that what we did was build the building blocks for each of the pieces of the game, and then don't mind the food. For each of the pieces of the game, so the terrain, the different units, the NPCs, and what we do is we procedurally generate all the elements of the game so that every single time you play, it's a unique experience. All the entire interface between you and the game is through input using the Amazon Echo, and we do all this processing on Amazon Web Services. And yeah, that's the hack.
Very cool. Do you have any screenshots you can show us or super fast demos?
You want to pull up the dev post? Oh my goodness. Can you pull up the dev post, please? Just go on dev post / yeah. I'm sorry. You guys can edit this out, right?
Yeah.
Oh, sweet. We weren't expecting
No, it's all good.
interaction. If you'll click idiots, we'll edit it out. Don't worry. Dude,
So the whole thing, right? Just take
Yeah.
us out of the whole. All right.
Why did you go 21, 22, 23, 25.
Alexa. Oh, right. No, that's a hackathon. Oh, sorry about that. HopHacks 2016. A little more hackathons. Oh, is it still applying to search? Sorry about this. HopHacks. It's early. Yeah. Oh, certainly. Oh yeah, yeah. We were literally just sleeping like a few hours ago. All good. Submissions should be open still. No.
Word. Can you just hold that for 1 second?
Like, how do you search for this stuff?
Just having some quick technical difficulties while they pull up some slides. Not much is going on. We got some judges and sponsors starting to filter into the room. Everything's becoming very legit. Lots of people getting very excited, hoping to win some cool stuff. Tucker's hiding just out of the frame. I'm trying to catch him, but he moves pretty fast. But Jordan's not so quick. I can catch him. He's not very good at hiding. Cool. All right.
It's all on here.
Oh, yeah.
But
Yeah, so unfortunately we don't have very many screenshots because this is a completely voice-driven app. But we do have a little landing page here that kind of explains like the features of the app. If you want to just scroll down.
here, just
I think John didn't do that. Yeah. So basically what we think is impressive about this hack is the fact that we were able to kind of build out 90% of a game in one weekend. So this includes a class system where each of the classes like that your character can be have different stats and abilities. We built out at least 6 different terrains that can spawn randomly throughout the map, and each of them affect you in a different way and provide different challenges and obstacles. We built several different monsters and NPC units that can generate in each of the different terrains. We built in an item system and a way to trade and buy for merchants and stuff, and use stuff like potions and everything, and it's all completely voice-driven. There are kind of like a lot of applications to this. I mean, it's a fun hack that anyone can just enjoy. But kind of something that we thought of while we were working on this was, as developers and as fellow video game players, we often struggle with, eye strain and stuff like that at times. So it's kind of really nice to be able to just sit back, close your eyes, and kind of just go through this imaginary world with assistance of your Amazon Echo. Yeah, digital D&D is essentially what it is. I mean, it would be really cool to someday be able to like add the ability to spawn multiple players and just kind of take turns. You theoretically could like make digital dice and roll some crits or something. Yep.
Cool. Thank you guys.
Yeah, thank you.
Good luck with the judges. You guys mind if we give you a quick interview?
All right, cool. So tell us what you did. Tell us about your hack.
Okay. What's this for?
This is just to,
for posterity.
Yeah.
Oh, okay.
And the sponsors like
Gotcha.
to review it later.
So how long? Like 2 minutes?
Just say what you
Okay.
gotta say.
Yeah. Okay. Yeah, I did my project. Basically, I have. So I'm looking at apartment websites and scraping them to get out information so you'd be able to price the market. So I looked at 3 different cities: DC, San Francisco, and New York City. And I went to a couple different apartment websites and pulled off I'd pull off as much information as I could. So they have a really nice web scraper. It's webscraper.io. And then I also used the Merga. It's a mouse recorder, so I can show you that. So this is apartments.com, and so I'd go in and I would take these, they have these HTML blocks, these elements, and I use webscraper.io, and so I would go through each one of these elements, and I'd take each block was a property, and then I'd scrape these 7 different pieces of information. I'd use Merga, so basically Merga travels around the screen. And so So yeah, it would travel around the screen, navigate through the website, pull all the information off, and then once I had all the information, I would clean it up. I used Ruby to just polish it up so that I could put it into the Google's. Google has their prediction API, and I use that. And so once the data was in a form that I could upload it, I put it in the cloud, put it into a custom model, and then I would run it for different sets of both user and someone who's trying to sell apartments. So anyone who has an apartment to list, they'd be able to go on, find out how much they'd be willing to list it for in order to make the most profit. And for my friends who want to use it, they would be able to go in and see what the best deal is and how good of a value they're getting for any apartment near wherever they're working. So they'd be able to figure out, they'd be able to know if they're doing well in the market, if they're doing better than average, if they're doing worse, and then they can also look at how close they are to where they work and decide if they're getting a good deal. So yeah.
Awesome. Thanks. Yeah. All right. So we're gonna head over here, back to people we missed. Okay. Cool. We were wondering if you guys might like to tell us a little bit about your project. Yeah?
We're Team Atlas, and basically what we did was created an automated tagging system using image recognition and an OpenCV called TensorFlow. And I guess to provide more technical details, I'll allow him to explain first because I have an idea of what the higher level understanding is.
So I'm Sean, and one challenge that most people face, like some people have hundreds of videos on their phone, and there are very limited possibilities of searching through all of those videos. Because normally, if you're trying to look for a specific video of you, like kayaking, you would have to, either scroll through all your videos and look at the thumbnails for, a relevant picture. So what we did, the purpose of our project was to automate this tagging of videos, and we labeled these videos, and then we gave the option to users to search the videos given those automatically generated tags.
Cool. So the problems that we're trying to help solve here, one example is, say that there was one that happened at Hopkins a couple weeks ago. Somebody was basically there was attempted kidnapping on the side of campus, and there were CCTV cameras that were recording it. It took the campus 48 hours in order to go through the footage, find it, and basically send an email out to the campus community. With this program, it can go through the footage a lot faster than what a human can, and it will be able to identify the frames, the images that are needed a lot faster.
Also, I think a problem that it addresses is it can use facial recognition through Facebook tagging. So also in the instance of Hopkins, they would able to be, if she was connected through Facebook and tagged, they could search her name and actually locate her and figure out who it was. Yeah. So yeah, and I think like the biggest issue that it's addressing is like time and efficiency. Like it would take a human a lot more time to go through all the videos, whereas this is an automated system and it could do it much faster, and it'd be much more productive.
So I guess we want to thank you for your time, but one more last note is, so specifically speaking, I guess I won't really get into the technical details, but there's a lot of research and development in this field, and also a more complicated array of issues that happen in the medical field as well. There's a kidnapping or something that's probably really intense and probably probably something that we can't really I'm sorry, I'm brain dead. Can I just can I cut out? Yeah.
You guys want to just give us your names real quick?
Yeah.
Brandon.
I'm Sean.
I'm Michelle.
And I'm Charlie.
Awesome. Thank you guys.
Good luck with the judges.
Yeah.
I know.
All right. Shall we head over here? All right. So, where are you guys from?
We both are from Howard University. We're from Howard University, and I'm from University of Maryland, College Park.
So why don't you tell us a little bit about your projects?
So we're Groupify. So what we do is we're basically like Tinder for hackathons. So what we do is we team up people according. So what we do is we team up people according to their experience and whatever the languages they know. So as you can see there, this is a basic sign-up sheet. This can be used by any hackathon. Once like the deadline passes, this sign-up sheet automatically like forms groups from the database that it got, and then it sends out emails to all the team members of the group. So we just tested it, and yeah, something like that comes out, so that like you can reach out to your group members, and you get their Jira profiles, you get their number and everything, so that you can like reach out to them and talk about like what you want to build. Because we built this because of the experience we had yesterday. We being freshmen and having very little coding experience, like we had a hard time getting stuff done. So yeah, taking that in mind, we built this so that like people who have very little coding experience can get teamed up with amateurs and professionals, so that like an hackathon is a good experience for them. So yeah, that's Groupify for you.
Hey guys, give us your names real quick.
I'm Arya.
I'm Nishal.
I'm Susan.
Cool. Awesome. Thanks, guys. Good luck. All right. Shall we hit the other rooms? Lead the way. Is it really not that sensitive?
Really bad.
Oh, okay. Ah. All right. Shall we just start at the bottom? Start it from the bottom. Yeah, this is about to be rough. Everyone's gonna have to make sure to speak up. Hi. One sec.
There we go. All right.
How are you guys doing?
Good. How are you?
Good. So where are you guys from?
Northern Virginia.
Dallas, Texas.
Dubai.
Awesome. All right. So can you tell us a little bit about your project?
Yeah, we would love to.
Hold close.
Okay, sure. Okay, so basically we decided that people have a lot of difficulties dealing with face-to-face interactions nowadays. We're so embedded in our technology, our smartphones, our tablets, and it gets a little difficult when we're in one-on-one conversations with each other. We developed a solution for that, and it's called Smart Talk. It's a Pebble Watch app that basically allows you to have various settings to choose from. They range from things like your date nights, to parties, to family interactions, to being with a professional colleague. And if you're ever in that setting and conversation gets awkward or you're unable to keep it going, we have the opportunity and the option to choose a setting and then basically have randomized conversation starters appear from that. The conversation starters range from pretty quirky questions to more serious ones depending on the setting that you're in, and they basically allow you to kickstart any kind of social interaction that you would have and make things flow a little better between you and this other person that you're with. We hope that this will help improve social interactions between people and improve basically the human relationships that we create.
Awesome.
Yeah.
So can we get your names again?
Yeah, sure. So I'm Nehan Tiru.
I'm Zanar Habib.
I'm Saksham Bhandari.
Awesome. Thanks, guys. Good luck. All right. Where to? Do you want to go over to the side since he's over there? All right. Do we have other mics? Damn. All right. Hey, guys. How's it going? So can you tell us your names and where you're from?
I'm Bilal Sadek. I'm from New York.
I'm William Sun. I'm from New Jersey.
Awesome. So why don't you tell us a little bit about your project? Yeah.
Should we run you through the presentation?
Yeah, you can run us through the presentation. You can do something kind of informal. Just make sure to hold the mic close because it's.
Oh, okay. All right. So basically, one of the major problems in our country today is that the out-of-hospital the out-of-hospital survival rate of cardiac arrest is really low. It's only 9.5%. And what makes this even more frustrating is that you can actually predict a cardiac arrest 3-4 hours in advance if you have like proper sensor data and you make some calculations. So I've been doing research with the Microsoft Band 2, and I realized that a lot of the sensor data that I had could also be used to predict cardiac arrests. And even furthermore, we could also use it to predict other adverse events, such as falls or car crashes. And so we've developed an Android app, Overwatch, and basically it is supposed to predict cardiac arrests or detect crashes/falls. And when this happens, an emergency contact will be texted so that they'll know of this happening, and they'll be able to manage the situation as they see fit. So as a demo of our app, here, let me just pull it up. Can you hold this up? Yeah. So as you can see, it shows a bunch of different kinds of sensor data. Do you want to run them through all of them? Yeah.
All right. So first we have heart rate. That goes actually hand in hand with RR interval when we're calculating the probability of a cardiac arrest. I'll get more into how we do that later, but essentially RR interval is the time between heartbeats. So if you're thinking about an EKG machine, how it has various spikes, it's the time between two peaks. Then there's a change in altitude. We use that to help predict falling along with the accelerometer, because a big problem we ran into was the difference between falling and going downstairs or going down an elevator or sitting down. So the altimeter really helps with that, with the rate and change of altitude. And the GSR, or the galvanic skin response, helps determine stress levels, which is also useful in our calculations. So do you want to? Thank you. All right. So the way we detect a fall or a crash is with the altimeter and the accelerometer. So there are three main stages to a fall. The first is free fall. There's essentially zero gravity on the person as they're falling. It's that weird phenomenon of free fall. Next is impact, which is kind of the opposite, a rather high G-force. That's when someone hits the ground. That's the part that hurts. And the next stage is the aftermath. In more severe falls, a person will usually remain still for up to 2 seconds afterward. So basically with our accelerometer data, we're looking for very low G-force, followed by very high G-force, followed by very constant G-force. The cardiac arrest prediction is interesting. We're using a simplified formula because of the scale of this project. Essentially, we're taking heart rate, and we're seeing if it's within a healthy range. If it's not, that's one indicator. And then we look at your RR interval over the last 5 seconds. And essentially, like I said, RR interval is the space between heartbeats. So if your heart's beating very fast, you have a low RR interval, and vice versa. So if you look at the standard deviation of your RR interval over, say, 5 seconds, you'll see how much variation there is from the mean time between heartbeats. If that's a high standard deviation, you know that your heart is palpitating because you have a few fast beats followed by some very slow beats and back and forth. So if there's a high standard deviation, that's also a huge indicator towards cardiac arrests. Yeah, exactly. Because when you exercise, it gradually goes up and then gradually goes back down. Do you want to?
Okay, now we're going to do a demo of the functionality of the app. So we can't really simulate a cardiac arrest on demand. So we're going to make do with a fall. And I'm going to be dropping the watch. Yeah, there will be a notification on my phone, and you can probably hear it. But more importantly, Bilal is going to be getting a text message. Yeah. All right. So here we go. And Bilal's text message says, Will's health is in poor condition. A fall has been detected. So the text message also says, like, what kind of event has happened. So as for future development, as Bilal said, our cardiac arrest detection is a little basic right now. There are actually some applied machine learning algorithms out there right now that can give us a 95 to 99% prediction, successful prediction rate. So in the future, we would consider processing it in that way. In addition, we might want to use better suited hardware because, like, for example, on the Microsoft Band, the ticks between like each point of data, it's sort of small. And if you hit the wrong tick, then like you might not actually see the impact of a fall. And finally, we're considering moving the platform from like a phone app to just the watch. So if you look at Bilal, he has another smartwatch. It's an Asus Zen watch and basically has its own processing. It's connected to Wi-Fi and everything. And hopefully in the future we can make it so that everything is on the watch and he doesn't have to carry his phone around. And that concludes our presentation. Yeah, sure. I'm William's son.
I'm Bilal Sabiq.
Cool. Thanks, guys. Good luck.
Yeah. Hey, my name's Christian. I'm taking over as MC. Cool.
Lead the way.
Okay, lead the way. So.
We've done them and the group right up front, and that's it.
One up front? Oh, cool. Okay, cool. Do you mind going all the way over there, or is that too far? Looks like they're. Hey. What's up? How are you? So, we're here to videotape you we're here to videotape you and see what project you did over the weekend. So, do you mind giving your name?
Sure. My name is Matthias.
Matthias, okay. And hold the mic. What room are you, what school are you from?
I'm from Johns Hopkins University.
Okay, and go ahead and give your presentation.
Okay, so basically, we are Touch Plus, and there are 285 million people in the world who have some sort of visual impairment. And out of those 285 million people, at least 39 million, say estimates, are totally legally blind. So our idea was, how can we help them not only feel good, but also be able to experience what's around them. Not only see with a cane what's right in front of them, but also feel what everybody is seeing. So after some thinking about new ideas, we came up with what my teammate Brandon is using right now. So I'm going to give the microphone to Brandon, and he'll explain to you what he's using.
My name is Brandon Duderstadt. I'm a freshman here at Johns Hopkins University, majoring in computer science and applied math statistics concentration. And I worked on the Touch Plus project. Now, what is Touch Plus? As my friend Matthias explained to you just now, Touch Plus is a way to help the 285 million visually impaired people of this world feel a little bit more at home. No pun intended. So, what we're going to start off with is, I'm going to start in the resting position. As I raise my hand, this is going to begin giving me haptic feedback.
Right.
Feel it start?
Yeah, it's starting.
You feel
And
it
it's
stop?
gone. Yep, it's gone. Okay.
Bringing it back.
Yeah.
Now, this haptic feedback is responsive to depth changes. For instance, I'm going to sweep from here over to your friend. We've now got a faster beat, slower BPM. Now, this is not the only thing we've done. Well, first of all, this faster BPM, when you're coming towards objects, is going to allow you to know how far an object is from you. It's giving you that almost sixth sense, that Touch Plus, looking for the distance. But we here at Touch Plus recognize that you might not always want that sort of very, very strong response. So what we do is we leverage your position, or your arm's position rather, in space with the Mayo armband. So I'm right here, sensing him. And then if I were to drop it down, that sensing is going to be much, much less because the Mayo is able to understand that your arm's position in space is lower. You're not looking ahead of you for the large changes. You're looking for smaller changes that may be on your desk.
Right. Okay, that's cool. That's cool. So what were the sort of things that you did to implement this? So what are we looking at right here?
All right, well, what you're looking at right now is a prototype with a Xbox Kinect on the front. The Xbox Kinect was used only for the IR sensor on the front. This means that in other versions, final versions of this product, even future versions of this product, we would take this large bulky sensor on the front and this very, very crude but still very, very cool 3D printed mount that one of our other team members made. And we would be able to break it down into something that's a lot smaller and it uses a lot less power. In fact, we tried to get it working off of the Arduino and the battery, which we were able to run it relatively well. Unfortunately, the Bluetooth interference from other projects in this room is sort of getting in the way of that, so we're keeping it tethered. Additionally, because it's only IR, every function that I've shown to you today will work just as well in the dark, meaning that we give those visually impaired people the power to see better than you in certain situations.
That's awesome. That's awesome. And so you have the Mayo as well working on there.
That's correct. Yeah.
Okay.
So the Mayo armband's a large part of this project. We use it for the position of the arm in space, when to turn this on and off, and obviously for the haptic feedback, the number of beats per minute, the frequency at which you can understand how far the depth is from you.
And so what were some of the problems that you had with this project?
I would say that we had a few major roadblocks. First one was interfacing these two devices together. This Connect is running in a piece of C++ code, and this is running in the Mayo rather, is running in a piece of Python code. Now, unfortunately, the Python code that we found for this was a wrapper. That's the only thing that we could get to work on our Linux systems because eventually we do want to get to the Pi, so we run everything through a Linux system. And this wasn't exactly designed for that. So we had to interface those two items and basically have two instances of the program running in threads that could dynamically change information. So we wrote our own runtime dynamic pipeline to be able to exchange that information between the Mayo and the Connect and back. And actually our latency has dropped to like tenths and hundredths of a second. So very, very fast response, as I'm sure you felt before.
Okay, cool. So do you have any last remarks for the camera?
Last remarks for the camera? Not particularly.
Okay, cool. Thanks. Names?
I'm Brandon Duderstadt.
I'm Matthias Eisler.
We're out.
Thanks, guys.
Cool. Thank you. Okay, hi, this is the first time I'm listening to this.
Fewer follow-up questions.
Okay, cool. Cool. Okay. Hi, so can I get just the three of you? Can I get your names and your schools and your majors, I guess?
I'm Tim Zolf. I'm majoring in econ.
Ibrahim Hashmi. I'm majoring in mechanical engineering at the University of Maryland.
Hi, my name is Kunal Sharma. I'm a computer science major at the University of Maryland.
And so can I just get the presentation?
So we built a smart shower head that detects movement underneath and turns on. It opens a valve as soon as it detects someone's in the shower, and it also measures how much water is being used and reports that to a web app so users can like go to their profile and check out how much water they're saving by having shorter showers and stuff. It also was supposed to be self-powered because high pressure water can turn a turbine and that powers the thing, but we can't do that because we don't have a high pressure water system available to us. And yeah, that's our hack. Thanks.
So what kind of technology am I seeing?
Kind of what technology? There's an Arduino Uno, there's an XB Wi-Fi shield which connects to the computer through the Uno, and there's a bunch of servos to open the valves, there's a battery pack, and there's two IR sensors to detect movement and like the depletion of water. Yeah.
So you guys are called Drip Drop. Is that your team name?
Yes. Drip Drop. Yeah.
Okay. Yeah. Cool. Do you have anything else to say about your project?
We had a lot of ambition, and we wanted to like build this bypass system with another water tank that takes all the initial cold water you normally get before you get hot water in a shower, and then sends it back to the water heater. But we couldn't do that because we didn't have plumbing equipment.
Yeah. That's fair. All right, thank you guys. Can I get your names and one last time?
Tim Zolf.
Ibrahim Hashmi.
Kunal Sharma.
Thank you. Was that too short or was that good? Sure. Sure. Which team are you looking at? Okay. Is this live? Okay. Hi. Hi. To interview you. Okay.
Our project
Yeah. Your project.
We're demoing down there,
You're demoing down there. Okay.
So do you want to come later or do you want to come now?
Did we get you guys already?
No.
We'll get you down there.
Okay.
Okay. Are you demoing? No. Okay. Everyone in the rows are demoing. Oh, you could go over there. Cool. Hey again, guys. Hey. So we're here to interview about what your project was this weekend. Again. is my second time. So if I could just get your names, your schools, and your majors.
I'm Colin from University of Maryland, College Park. I'm a mechanical engineering major.
I'm Yash from University of Maryland, College Park, major comp sci, freshman.
Hi, I'm Vijay Sadashivaya and I'm from Biomedical Engineering, Johns Hopkins University.
I'm Juhi Bhaskar and I'm from Biomedical Engineering, Johns Hopkins.
Okay, and then I guess can I get your presentation about what you guys did?
Okay, so we're using the Mayo, which it sends EMG data to our computers. EMG is like electrical impulses from your muscles. So we're using this EMG data to calculate steps and steps per minute. And then we match up a song to your steps per minute that has the same number of beats per minute as how fast you're walking.
As you said, the main application that we are doing right now is to match the steps per minute and play a song so that it actually motivates the runners to do more. And that's one of the main applications. And apart from that, we're also trying to measure the fatigue that the muscles take up when you're like say lifting a weight or running for a long time. And we want to use this fatigue in order to give a feedback to the athletes, telling that if they're doing like way too much and straining themselves. This is like a main application because there are like most of us work out, like at least like as far as I know. So it's going to be a really important like a mass application for many people. So this is one of the applications, and she's going to talk more about what we want to do in the future.
Okay, so right now first we could give you a demo, but because of the setup situation, he's going to be walking while he's going to wear the headphones, and if you could notice how fast or slow he's moving, he could tell you if the song actually matches.
Let's give it some time to sing.
Yep, so we have a 5-second delay at first. Yeah.
This is for syncing the...
Yeah.
Yep.
Okay, music is playing.
Okay.
Pretty
running faster.
Pretty slow. Okay, it turned into club music. This is pretty fast. Yeah, this is pretty fast. It's like club music. Can you hear it? No.
Connected. I'm not sure. It'd be too loud. Okay.
Okay. Okay, now there's like more bass and it's really fast because you're going really fast. Okay. Yeah. No. Yeah. It's really cool.
So, I mean, this could be used for a lot of things. I mean, drummers could use this as a guide to follow the beat, or we could kind of reverse it, and dancers could use it to try and make sure they're catching the beat. People are learning. So, I mean, there are a lot of ways we could use this.
Cool. That was a really cool project. Double the features. So, if I could just get your names one last time.
Yeah. I'm Juhi Bhaskar.
My name is Vijay Sadashivaya.
Yash Upadhyay.
Colin Ayers.
And what's your team name?
Team is My Own Jam.
Thank you, Maya Jam. We got them already. Are we going through everyone?
As many as we can.
Okay, cool. You guys ready yet? You guys still down there? Still down there. Okay, always down there. Okay. Yeah, right here. Hey, are you guys available for a project? Okay, hi. I'm Christian. Can I get your names, your schools, and your majors?
I'm Cyrus. I'm from Johns Hopkins, and I'm a Masters of Security Informatics student. Yeah.
I'm Harsh. I'm also from Johns Hopkins. I'm MS in Security Informatics.
Cool. And so I guess could you give me a presentation or what you did over the weekend?
So, what we are working on is Portnort. So it's portable snort, and hence the name Portnort. So what it does is, so these days everyone needs Wi-Fi, everyone needs internet connectivity everywhere. Like people either go to Starbucks or where they would access free Wi-Fi, or they would go to airports where they would access free Wi-Fi. But the thing is that attacking over the network has become so easy that the script kiddies will always be trying to prove a point, and they'll try to maybe attack your system. So what we thought was there has to be some small device that could take care of the security and you can just be relieved when accessing non-secure Wi-Fi networks. So this is our device. We call this port not, but it's actually a Raspberry Pi. It's a very secure. I mean, it's been hardened and it has a lot of security features like firewall, which has been implemented by IP tables, and it has snort intrusion detection system running on it. So what it actually does is, the other good part about this is, right now the frills, the wires that you see is just for the presentation. Otherwise, it just comes with a battery and two Wi-Fi dongles. One of the Wi-Fi dongles would create an external hotspot, an internal hotspot, where all the legitimate people can join that hotspot, and the external dongle would connect to the non-secure Wi-Fi. All the traffic would be tunneled from the external dongle to the internal dongle via the intrusion prevention system and the firewall. So whatever attacks are might happen would be taken care by the intrusion prevention system in the center. So you don't have to worry about you getting attacked while you are trying to access free open Wi-Fi. Yeah. Sure. Yeah. So you want to talk about it?
So this computer represents the attacker, and this computer and the portnot currently is there are two. Both of them are in the insecure Wi-Fi network. Oh, sorry. Both of them are in the insecure Wi-Fi network, and this one is the protected computer, and the portnot shares the same hotspot, which is protected by portnot, which is in the internal network that we created. So now we want to do a demo of. Yeah.
So what we'll do is the attacker would try to ping sweep the network that we are connected to. So we'll see, we have put snort in intrusion detection mode, so it is in promiscuous mode right now. It will just tell that there is an attack happening, and it won't stop it because that's not the point here. And I have put snort in total verbose mode so that people can see what is happening. All right. All right. So I'll start snort now. Oops. Yep. So it's loading all the rules, making a rule chain out of it. And now it started listening. So now the attacker will try to do a ping sweep. The attacker would try to do an IP ping sweep. So so it started alerting. Started alerting that there is an attack happening and somebody is trying to ping sweep you. It will generate alerts, and these alerts will also go in logs. So you can actually write cron tabs, cron events that you can continuously use to assess the logs after a couple of days. Yeah. So that's about it. And by the way, so yeah, it's working right now. So it's able to tell that there is somebody is doing a ping sweep on you. And this laptop on right now is on the portnot network, which is the internal connected network, and it is able to go surf on the internet perfectly fine.
Thank you so much. Okay, if I could just get your names one more time.
Cyrus.
Harsh.
Thank you. And your team name is Port Nort. All right, thank you. All right. Next team. This team. Hello. Hi. My name is Christian.
Elliot. Nice to meet you.
Your name is
Elliot.
What school do you go to?
I'm high schooler.
You're a high schooler, and you are in which kind of study?
No. Well, my program is called International Baccalaureate, so I'm still a high schooler, and I don't have computer science at all at my school. But I will take computer science in college once I get there. Okay. I'm a senior now.
And your name?
My name is Wei
Your school?
UMBC.
And your major?
Information systems.
Cool. Sorry? Okay, and what kind of project did you guys do this weekend?
That's an excellent question.
Okay,
So
so talk into the mic.
Sure. And I will start with a question to you. Have you ever learned a language, foreign language?
Yes, I have.
Which one?
Spanish.
Wonderful. Remember when you were learning Spanish, in textbooks that you used, all the words and phrases were structured based on some kind of theme related to a specific situation in life. The first one was probably introduction. The second one was something like animals, food, transportation, and so on. We thought like, okay, that's a very efficient like learning technique. But what if we can add some level of interactivity to it to make it more, you know, like an augmented reality experience? So what we did to build an app called Lexicon. And this is an app that shows you words and phrases in the language you learn based on the location, based on your location, based on the place in which you're in. And what it does, it uses Foursquare API to understand where you are, and takes the data from our Firebase and displays it to you in a very like intuitive manner. So it works on both iPhone and Apple Watch. So you can use it on the platform which is more convenient to you in a very glanceable manner. So let me demo it for you. I just love my launching screen, so I will launch it. Our cute little logo. And this is the main screen. It's understood that we're in university, and the targeted language is set up for Russian. So your English speaker learning Russian, you see how the word is written in Russian, how you pronounce it using English sound, and the translation too. All the words get saved in the history tab, so you can revise them for later if you want. And every time you come, let's say you came to the same place 2 times, the same category of place, every time you'll get slightly different type of words. So you'll always learn something new, you'll keep always revising. We are planning to add text-to-speech and speech-to-text features, so the app will pronounce the words for you. It will be able to check how well you pronounce words. And also we're putting a lot of attention on gamification, so it will actually show how many locations you've unlocked, so the user will be encouraged to open the app more frequently. So we're actually planning to release this app on App Store in the near future, like 1 or 2 weeks. We're starting with 5 languages: German, French, English, Spanish, and Russian.
Okay.
And for like monetization manner, we will sell additional location and languages as an in-app purchases. So that's Lexicon, our nice little project.
This is a very beautiful app. I don't know if you got that on the camera. I was just wondering where you got the data from, like what kind of data you're using for languages, what kind of data you're using for phrases.
So for phrases and languages, we just borrowed them from currently existing textbooks, which were designed like by Oxford professors. So they're very well written. We just bring interactivity to them. So we put those different languages into our database and just show them to user when needed.
Okay, cool. Thanks. This is a really cool app, and it's really beautiful. So if I could just get your name one last time.
Elliot.
Weijin.
And this is the Lexicon app. All right, cool. Thanks. Did you see how beautiful that was? That's a beautiful app. All right, so what's next? No, they're presenting. Do you want to go here? There's a team right here. Hello. HopHacks. Hi. I'm going around asking people what kind of projects they did. So my name is Christian, and if I could get your names, your schools, and your majors.
Andrew Fan, CS here.
John, I'm from Yale, computer science.
Cool. Sorry about that. And so I guess could you tell me about your project?
So our project is New York Time Machine, and it's basically a tool that allows users to you can select a region of the globe and a year, and get New York Times newspaper headlines and clippings from that time period.
So the way it works is that you input a year, and then our program will generate a random list of articles for you from specific countries in that region. And the goal is to give you a snapshot of A, what was happening during that period in that region, and B, what the coverage of the New York Times was like in that region.
What were some of the things you encountered, like problems you had during this project?
So we use AngularJS to build this, but none of us knew any Angular before this hackathon. So we basically spent like the first day trying to learn it. So that was the major challenge.
Additionally, Bootstrap sort of didn't want to work all the time, and there were some issues with formatting the forms as well as the input.
Cool. So can I demo could you demo your app?
Of course. Choose a country.
The United States. Okay, so North Africa. 1990s. Just 1990. And then it's giving me Libya, Jordan to restore Libya ties. Official says there are only 3.
Out of all the so the way our program works is that it takes from the region. It has a list of countries, and it will select randomly from those countries, and from the countries that are selected, it will find articles based off of New York Times queries.
So the goal is just like give a small snapshot as opposed to like giving a complete historical record.
Cool, this is really cool. Thanks, guys. If I could just get your name and then your team name after that.
Name, as in Andrew Fan.
John, and our team is New York Time Machine.
All right, thank you. Thank you so much. This one, they're both getting judged. Hey. So we're going around asking people what they did over the weekend. My name is Christian. Can I get your name, your school, and your major?
All right, my name is Ben Zan, University of Maryland, College Park. My major is computer science.
My name is Rory Ulay. I'm also from University of Maryland, College Park, and a comp sci student.
Okay. All right, awesome. So if I could just get you to explain your project.
All right. So I guess a lot of you watch YouTube, right? So we basically made a YouTube for people with visual disability or people who are blind. So Roy's gonna do a little demo right here. Basically what happens is when you launch a YouTube website, say you search for some video and then a lot of search results come up, but you have no way to say you cannot see, you're not gonna know which one to click. So our application here basically indexes all the videos you see, and we use a voice narration to help blind people to know what they are doing. So he just launched the app. It's kind of noisy here, but basically what it says was, welcome to the app. What would you like to search? And this is the same thing as if you were in the YouTube search bar yourself. So give us a keyword. Bananas. So let's type in bananas. So once you hit enter,
Okay, so it's giving a list. I'm hearing a list of videos.
You're gonna see it later. Yeah. So what happens is it's giving you the top 5 list of the videos you would normally get from the real YouTube website. So let's wait for a second, and then it's going to tell you the options you do. It's pretty loud in here, so you really cannot hear, but yeah.
I can hear it.
Okay.
It's saying view for previous page, all that stuff. Okay.
Right,
And then it gives
right.
This is just for you guys to see it.
Right. So, but if you're blind, you're not going to be able to see all of that, so it doesn't really matter. And at this point, you can select any video you would like to watch. So to do that, the option says press W to watch. So pick a video, any. So W and then the index number, and then hit enter. So now you see this tiny bar. The reason why we made it so small is we believe if you cannot see, you're probably gonna hear the video, right? But if you do wanna see the video, it is a fully functional YouTube video that we're streaming, right? So even though we're streaming, it has all the functionality you will get, like pause or like fast forward, right? So everything you get from a normal YouTube video. And yeah, so that's what it does. We never used any YouTube API. What we did is we simply streamed the video from something in Python called Beautiful Soup. The benefits we get is that we're only streaming the video, so you're not gonna get any ads that you would normally get with a traditional YouTube website.
Yeah, that's basically pretty much well. Okay, cool. Yeah. And if I could just get your name and your project name, your name of individual and the project name.
Yeah, my name is Ben, or Beiji. Project name is called Soundy.
Soundy, and my name is Ryu.
Cool. Thanks, guys. This is a really cool project. Hello. Hi, we're going around just interviewing people, seeing what they did over the weekend.
Yeah.
So if I could just get your names. My name is Christian. Your names, your majors, and your schools.
I'm TJ. I'm computer science here at JHU. We're all JHU students.
I'm Rohan. I'm a biomedical engineer at JHU, as he said.
I'm James. I'm BME.
Himanshu, BME.
Cool. And then can I just get the whole presentation?
Yeah, sure. So, okay. Yeah, okay. So our app is called 2 a.m. And we came to this hackathon with a very basic idea, which was to create a convenient app to help users evaluate how impaired they are from how much alcohol they have been drinking that night. So we approached this with a very unorthodox method. Himanshu and I actually went to the freshman dorms over the weekend during the actual hackathon, and we met sober and inebriated people, which was very convenient because it was also rush week, so we met a lot of both kinds of people. And we were able to collect data from them by asking them to perform 3 series of tests. One was a line test where they were supposed to walk along a line with a gyroscope in their hand measuring how much they swayed. And the second one was asking them to type a sentence and seeing how many words per minute they could type. And the third one was a basic reaction test. And from the 3 tests that we asked them to perform, we found a strong correlation between how much alcohol you've been consuming that night and how impaired you are. And through those 3 tests, we were able to design an app to assess how impaired you are that night.
Right, so the app starts off on this main screen here. This is called the BAC logger, and this is one of the most important parts of the app. It manages your blood alcohol concentration. So this is unlike anything else on the market currently because it's dynamic. You can go online and you can get a static calculator, but that's a one-time thing. This, you can log your drinks into it all night. Change your change your attributes, weight, age, gender. You can enter custom drinks. You can, and then of course, after that, it's gonna spit out a BAC, and it's going to tell you the time at which you will be sober with a 0.0 BAC. And then, of course, after this, perhaps you're done drinking for the night, you can move on to the exercise section, which is what the research is based on.
So the first test out of the 3 tests built into this app is the line walk test. So this, you've probably seen policemen do this. It's like you walk slowly holding, in this case, you'd hold your phone in front of you and you'd walk heel to toe. And you slowly walk in a straight line, and the phone gyroscope actually measures how fast you're twisting your arm, and if it notices anomaly, like you're twisting it too fast because you're losing your balance, it'll mark that as a flag, and if you get enough flags based on a threshold which is calculated from our research, you'll actually get the data. So they're demonstrating it, he's like swaying, and so later on when you get to the results page, you'll see that he would have failed this test because he was swaying instead of moving relatively still. And the actual threshold is based off the graphs that we got from our own research. So you can see for a sober person, the variance is relatively limited, whereas on the same scale you can see for an inebriated person, the graph varies a lot more, and that's an indicator of that they're losing their balance more often. And then the second test is the typing test, which it'll show a small character, a string right there, and then the user will have to type in the same string, and it measures their speed and their accuracy to calculate how fast they're typing, because especially if you're inebriated, you have trouble typing accurately. So in this case, he typed in a random sequence of characters, which is also going to fail this test. And the last test is a reaction test. It'll show a blue button, and then after a random amount of time, the button will change color slightly, like it just did, and then based on your reaction time to that, it'll fail or succeed you. So in this case, since he reacted slowly, it would have failed him. And since we had put in the initial blood alcohol as 0.09, in this case, he failed all the tests, which makes the app give you this result that you're impaired. But there's also other cases. TJ, you want to explain them?
Yeah.
So we can also deal with if you're intoxicated or not intoxicated, because you can be intoxicated and not show any signs of impairment, but you can't be behind a motor vehicle. But you can also be impaired and not be that intoxicated, and you still can't be behind a motor vehicle. So that's why on our app we also have some options. If you tap Get a Ride, it'll open up Uber for you so that you can get a ride, or it'll open a taxi service of your choice, or you can open a contact so that you can call someone and get picked up and get home safe. And the whole idea behind this is to try to get people to be more responsible about their alcohol consumption, especially on college campuses.
And so that's what it comes down to, right? So this has a huge value proposition on college campuses especially, and that's what we really wanted to focus on. We can see clearly that this is going to be paradigm shifting and change the way that students stay safe yet have fun at the same time. So we hope you liked 2 a.m. Himanshu.
Rohan.
James.
And TJ.
Thank you, 2 a.m. I don't know if we can get there. Can you do it from here? Hey guys. So, hey, I'm going around asking people what they did over the summer, or over the weekend. So, my name is Christian. If I could get your name, your major, what school you go to, yeah.
I'm Kim. My major is environmental engineering, and I go to Hopkins.
I'm Jake. My major is mechanical engineering, and I go to Penn.
And maybe just tell me what kind of project you guys did.
Okay. How long do we have? Like, normal project? Okay. All right. So we. Oh yeah. Okay. Sure. Sorry. So we created Footprint, which is a tool to help people understand abstract numbers having to do with climate change. So if I asked you, what's the carbon footprint of a flight, one ticket from New York to Hawaii? You might know the number, you might not, but even if you knew the number, it's hard to understand like what that actually means in terms of impact. And so we break it down into one of those flights is equal to powering 5 homes for a month. And powering one of those homes, well, that's the same as driving back and forth from New York and Philly 8 times. And one of those drives, well, that's the same as the carbon impact of 31 hamburgers. And just one of the carbon impact of 37 plastic water bottles. And one of those water bottles is approximately equal to viewing this website 34 times. That's approximate. And the idea is people love to talk about recycling, and recycling is a really big deal. It can help prevent 90% of the carbon emissions of those water bottles. But how many water bottles would you have to recycle to make up for the flight? Well, the answer is about 37,000, which is a lot. And suppose you did one bottle you recycled every single day. How long would it take you? 113 years. That's a really long time. And so the idea is basically recycling is really important, and it's especially effective when you get communities to recycle, schools to recycle, towns to recycle, where you have a large impact with a large group. But the point is to understand that by making small changes in other areas of your life, you can make a big impact that goes beyond even what you could achieve doing recycling, just by making small choices in those other areas we talked about. And basically we wanted to help anybody be able to understand those ideas, even if you don't have a technical or scientific background or have special education in this area. Anybody could come to this website and kind of understand what these numbers mean and get perspective from that. Yeah, it is. It's jakeweldy.com. It's my name, /static/footprint.
This is a really pretty website. Let me give you that. So if I could just get your name again and then your project name.
I'm Jake Weldy.
Kim Kuhn.
And this was Footprint. Footprint.
Okay, cool. Thank you. Really pretty and really informative. Can we reach them? Will it? Can we reach? Sorry? want to go to them. They did a really cool project. Vamsi and.
Once.
Okay. Hey guys. Okay. Hey. So my name is Christian. I'm going around asking people what they did over the weekend. If I could get your name, your school, and your major, that'd be great.
Hi, I'm Piyush. I'm doing Masters in Health Informatics from School of Medicine.
I'm Rano. I am from Johns Hopkins. I am doing my Masters in Security Informatics.
Hi, I'm Aditya Patil. I'm a master's student in Security Informatics from Hopkins.
Hi, I'm Hes. I'm also in the Security Informatics Master's program.
Cool. And then can I just get the presentation?
Okay, so we built a security app to help the security guards at Hopkins. So lately we get like a lot of security emails, people getting robbed. There was even a kidnapping attempt a couple of weeks ago, which is quite bad. So we want to help the students and the security guards a bit. So we built this app where you can actually ask the security guards to track you while you're walking home at night. So you can switch on Guard Me and select a location where you want to go to, a destination. And the tracking goes on. We have this control center where the person will pop up. He popped up here. Such that the security guards can actually keep track of him. You can see where he's going, and the blue ones are the security guards. So you can always send a nearby security guard. If I click on the security guard, I can see his contact info, and I can say like, okay, go check out on this person. But of course, if you're really in need, you also have the emergency button. So we have here the emergency button. Same thing, you click on it, immediately it shows up in red. And this means like, okay, we need to send a security guard there. There's something going on. But of course, pressing an emergency button could be hard if you have to take out your phone from your pocket. So we also built a Pebble app, which has the same functionality, very basic, start, stop tracking, emergency button. Same thing, and they show up on the map.
This is all being done. So the location is being updated. So when you move around, so this is what we did like last night at 3 a.m. So we were like, so Rano was moving around, so it actually updated in the map, and yeah.
So yeah, that's pretty much it. Yeah, our stack, tech stack is basically front end for the control center is based on AngularJS. We have iOS app and Objective-C, and then we are using Pebble as JavaScript SDK, and the backend is based on Node.js and MongoDB. Yeah. We hosted on AWS. Yeah.
When you said security, I thought you meant a different thing, but this is cool. Yeah, this is security. This is cool. Yeah, this is pretty cool. Thank you guys. If I could just get your name and then what your team name is.
I'm Piyush.
I'm Rano.
Aditya.
Yes. Soteria.
Cool. Thank you. With an S, not a C.
Probably the easiest pre-production platform you have.
Bye, Eric. Okay, hi guys.
Hello.
Hello. So I am going around and asking people what they did over the weekend. So my name is Christian, and if I could get your name, your major, and your school.
Sure. I'm Rob from Hopkins CS.
I'm Catherine from Hopkins CS.
Yeah, I'm Sui from Hopkins CS.
Cool. And then could you just give me your presentation?
Sure, why not? I'll take it. Sorry, there's food everywhere. So we made something called What's There. It's an iPhone app, and
in Hopkins, and I select this location and I add a quest. So I want to see a squirrel on the beach. I don't know how to spell it. And I present this request, and after 7 minutes,
And a subscriber will get a push notification.
you can see there's a new mission. Yeah, and I scan it. So here appears the mission and its area. Yeah, and I clicked it, and I accept the task. And suppose this is squirrel. I take a picture of it, and I upload it. It takes a while. Yeah. Yeah, it says it's posted. So this user in this area, he can check his history. It also takes a while. And yeah, here appears the squirrel photo taken by an unknown user. Yeah.
Okay, cool.
Yep.
That's your presentation? Yeah. So, what did you work with to get this?
We mainly worked on the Google API, Google Map API to accomplish this, because we need the map itself and also to drop the ping, and also all the photos are uploaded on the iCloud, and yeah, that's basically the technical part of everything.
Well, it's written in Swift. Google Map API, iCloud for all the storage is including all the subscriptions and all the push notifications because it's iOS and it's just the easiest to do it. And then for most of the buttons and the designs we used already made APIs, so it's just easier for design purposes.
All right, that sounds really cool.
What's there?
Okay, cool. Thank you guys. Can I go over? Excuse me.
We're hot swapping the battery. Just keep on.
Okay, cool. Let's go. So these are yours, and then this is a different.
Yeah,
okay. Okay, cool. Thanks, guys. Hello. Oh, you guys did a project. Cool.
Yeah.
So, my name is Christian. If I could get your name, your school, and your major. Could just hear about your project, and first your project name is.
It's Ucoin. Okay.
Okay, so our project name is Ucoin. So basically with this, we wanted to add a new way for YouTubers to engage with their audience in addition to educate the public about Bitcoin. So in essence, this application will allow YouTubers to donate money to charities through Bitcoin through a backend, and it's totally based on the amount of users who view their channel.
So this is how it works. At first, we use the YouTube API to access the views of the channels, and then we run it through a Python script to check if there's an increase in view since the last time I checked. If there is, then it will go through the Coinbase API and then access the user channel wallet and then donate their Bitcoin to charity that they choose.
So I can show you running really quickly. Hold the mic.
Oh, okay. Yeah.
So I have a YouTube channel that currently has 53 views on it. We're gonna fool the Python script for the demo purpose to show what happens when there's an increase. So say we wanted, say the last time I saw it, it had 50 views. So when we run the script, it's gonna have an increase of 3 views. The Python script is set so that 0.001 Bitcoins is donated for every view increase. So we run the script and we check over here. So 0.003 Bitcoins was donated, indicating 3 increase in views. And this was donated to Unsung, a charity in Baltimore dedicated to feeding the hungry. So And in addition to this, we have here.
Yeah, so we want to make this thing accessible to everyone. So what we have right now is a web app that you can fill out your information from your YouTube and Coinbase account, and then from there it will take your information to file-based database and then store it there, and then automatically run our script, and then help you donate to charity every time your YouTube channel has a view, increase in views.
So no backend or any code that users would need to write. So why do we use Bitcoin? Well, other popular methods of donating to charities like PayPal and Square take a transaction fee. But with Bitcoin, everything is there. Every time you donate, nothing is lost to corporations or nothing. It's all there. So this will just help the public be aware, because people associate Bitcoin with like the Silk Road or something like that right now that's like illegal money. But Bitcoin can be so much more than that. It's a really great innovation. So this is Ucoin.
And so if I could get your names one more time and then your project name.
Okay, so my name is Justin Chavez.
My name is Linchi.
And this was Ucoin.
Thank you guys. Really cool project. How long did it take? All day.
We started Saturday on lunchtime. The YouTube API took a whole lot of time. That was like the hardest part.
The YouTube API? Yeah.
APIs are just hard
Yeah.
to work with.
Only the second.
Yeah.
No, we're going this way, yeah. Okay, so let's go on to the next team. Hey, what's up? Okay, my name is Christian. I know you guys all. So I'm going around asking people what they did over the weekend. If I could get your name, your major, and your school.
So I'm Akshay. I'm a junior majoring in computer science and applied math and stats here at Johns Hopkins. Is there anything else I missed?
No, you got it.
All right, perfect.
All right. Hi, I'm Vamsi. I'm a grad student in computer science here at Hopkins. I finished my undergrad in computer science last year.
Hi, my name is Conan. I graduated last semester in December as a biomedical engineering major, and I did hackathon.
All right. Yeah. Oh, dang. Okay, cool. Thank you. And then can I get your project name and then, the presentation?
Yeah, exactly. Sure. I'll start it, yeah. Hi. So basically, our project is inspired from after watching The Force Awakens, and we couldn't wait for the next movie to come out. And then we realized it was going to be delayed by another half year. So we were like, screw it, we're just going to build our own scripts and make our own movie, and it's going to be better. So basically, ergo facto, here comes the Force Ghost writer. And it's basically a recurrent neural network that's trained off of the scripts of Star Wars movies, and we've trained it to the point where now we can actually generate our own novel scripts, and the scripts are actually somewhat coherent and make sense. Actually, we'll give a little bit more detail.
Yeah, so just to kind of work you through the details of this thing, this is sort of the general architecture of a recurrent neural network, and what you'll see is that as the inputs to this network, what we get are just the raw characters. So this model, it knows nothing about the concept of words, English language, nothing like that. All it knows is that there's a character following another character, and it has one hot vector encoding for each of those. So what it does is it looks at this character right here, and it decides, I'm going to put a neural network on top of that and compute some sort of a hidden state. And what this hidden state represents is it kind of tells you what's the context of the sentence at that point. What's been said so far, what still needs to be said, and this helps it predict what are the next letters that are coming up. And so we literally put that into a classifier and train it so that from this hidden layer, we can predict exactly the vector for the next letter in the sequence. And so if we do this enough times, it becomes very good at this, where you show it a letter, and then it updates its hidden state, and then decides based on this hidden state, I know what the next letter is going to be, or I have a probability distribution over the next letters. So then you just sample from it. You say, okay, it's a random distribution, sample a letter, write that down on the page, call that the next letter, and then once again, you can do that, update your hidden state, figure out what the next letter is going to be, and then you just keep on going on and on and on, and pretty soon you've generated a whole page worth of screenplay.
Exactly.
And so to wrap up the application itself, we have all this amazing stuff going on in the back end. And but on the front end, we kind of made a really simple UI. And essentially, there are 3 parameters. You can play with it, and those change the model parameters. Right, so those are, and that's right there. But I guess before we do a live demonstration, we can show you some of the results that we had. So on this page, there are 2 examples of scripts. Script 1. One is on the top, and one is on the bottom. And So if you want to take a little challenge for yourself, try to identify which one is the one that we generated and which one is the one that we copied from the Star Wars scripts.
That's it. That's
Yeah,
it for
that's
now.
it. That's
Now you go to the first one.
Yeah.
Looking forces a princess to see the force to get you to the shield zone. Okay, is that yours?
Yes, exactly. Yeah.
It is.
So you can see like how obviously you can see how we don't have like perfect like text generation, but that being said, given such a like small data set and small training time, we've been able to create structured scripts that not only physically are similar, like they understand the concept of dialogue between people, they understand the concept of setting up scenes at the beginning, like a description of what's happening in the scene, but on top of that it understands to put like multiple characters in a scene and have them doing something, and understands that these people can be in a place even though in the actual universe there's no actual occurrence where you have Princess Leia and Rey and Chewie on Dagobah's system. You want to talk a little more at the very end?
Oh yeah. So again, like I think it's really important to stress once again that this network that we're using, it knows nothing about the English language. It doesn't understand even the concept of words. So it has to learn from scratch how to string letters together to form words, how to string words together to form sentences, and how to do all this formatting in order to make something. Right. So you can see, like, usually with the screenplay, you start off with one character speaking. That character's name will be in all capitals, indented a very specific number of spaces over to the side. And then after that, the rest of it's indented again a specific amount. And it's learned exactly that right amount, so it lines up, all the way down the file. And it's really mastered the art of getting this formatting right. So even though it still has some ways to go in terms of getting larger concepts and maybe telling you a very compelling narrative, it's still able to learn a whole lot of latent structure starting from some incredibly low-level information about the training data.
And then the interesting thing to keep in context is that we had very little time and a small data set and a small network. Like the concept, like the potential of using something like this is that given a couple days or a couple weeks and a large enough network, you can really model language to such a degree that we could write scripts that just you can't even tell whether they were actually written by a human or written by a computer. And then Conan's going to give you a final live demonstration.
I'll just make it quick. So we'll show you how our thing actually works. So you can input 3 parameters. Number 1 is the seed. That's just how the script will start. Number 2 is number of characters. That's how long the script will be. And temperature is basically how volatile or how random the script will be. So I'm just going to click it for the sake of time, and it's going to start generating. So this is all occurring in the background right now. If you wait a few seconds, it'll pop up.
It's processing everything in the background on a server. And it's going to,
Yeah.
very fast. Exactly.
Yeah, so now you see it. And do you want to annotate it again? Yeah.
Sure, yeah.
I feel like you're best.
No, thanks. Yeah, so this is generated live in real time on an EC2 instance running on TensorFlow GPU processing, all of that. And so what you see is that already it's starting to get the general structure of, okay, Vader's saying something here, that all trouble. Like, you can see the words don't really make sense if you really try to think about them grammatically, but for the most part, they're phrases you can pick out that actually do make sense here and there. And so then we get dialogue with new characters being introduced. Han, in this case, Leia shows up as well. And as time goes on, you might notice that it starts to introduce new subtleties. So it might see a particular nuance somewhere and try to apply it in a new place where it hasn't seen it used before. For example, Leia right here says this line to Leia. Now, that sounds kind of funny when you think about it. Right, it's a monologue. She's just talking to herself. She's a loony bin. But what's really interesting, though, is that it shows that our network has learned that sometimes speakers will talk to other people with this kind of a notation. And while it hasn't yet figured out that people don't normally talk to each other, it's at least gotten to the point where it realizes that that's something that they can do, and it tries to apply this concept of talking to someone else in a place where it's never actually seen it being done before. So this is how it's able to mix and match concepts that it finds in the training data to produce results that are completely novel, even though they mimic the structure of the training data very, very well. And then, time goes on. We see Luke talking for quite some time here. A bit more other strange stuff happening in here. One thing which I always like talking about is you'll notice the indenting shifts a little bit. And so basically, you might be wondering, why is it that suddenly the indenting has shifted over right here? And the answer is that it comes from the screenplays that we trained on. So if you look at the screenplay for A New Hope, the indenting is fairly shallow. It only goes about that far. The screenplay for The Empire Strikes Back, for whatever reason, the writers decided to put an extra tab in there. So what it's done is it's actually built sort of a model for New Hope indenting and a different model for Empire Strikes Back indenting, and it switches between them. It doesn't just like look at it and say, you know, oh, it looks different here, it looks different there, I can't predict it, I can't do anything. Instead, it comes up with a special way to keep these things consistent within each other and go back and forth between these different styles of generating text, as opposed to just, you know, saying that it's too random to model. Yeah, I think that's basically all that we have.
Yeah. Could I get your name again and then your team name?
Of course, yeah. Vamsi.
Akshay.
Conan. And our team name is The Force Ghost Rider.
Cool. Thank you. At least I know it's not hard coded. It looks really cool, and it's really good words for character by character.
Thank you.
We've done everyone here. This is really cool.
Thanks, man.
I'd ask more questions, but it's 11:30. No, it's fine. Okay. Cool. And then we have one more room this way. One more room this way. Hello. Okay, so we're going around doing presentations, and my name is Christian. If I could get your names, your schools, and your majors, that'd be awesome.
I'm Claudia. I go to Johns Hopkins. I'm a molecular and cellular biology major.
I'm Layla Wahidi. I'm a doctoral candidate at Georgetown University in the government department.
I'm Robert Rose. I'm a comp sci freshman at UMBC.
I'm Robert Cranen, and I'm a computer engineering senior at University of Maryland.
Cool, thanks. And I guess could you give me your presentation name, your project name, and your presentation?
Wellspring. We are Wellspring, and we've created an app that aggregates and presents water quality data. So the EPA has a lot of data on water quality down to the water system level, and that can be pretty local. But this data is really hard to access. So to give you a sense, I'm sure you've heard about what's going on in Flint right now. And it really exploded in the news around December. But our data right now it's updated a few times a year. So we have data from October, and all the information was there, and it was publicly available. And so we don't know it was there before October, but I would be very surprised if it wasn't there. And if it wasn't there, all the water systems are required to report every so often, and if they don't, then you have a reporting error. So even if they didn't have the information then you'd know to be suspicious and to maybe do your own tests. So, but I suspect that they did. So. There was information, it's just hard to aggregate, so we wanted to try to make that easier. And this is especially pertinent for us here in DC, because we don't always have potable water. Every time the Potomac floods, then you get sewage overflow, and they have to tell everybody, don't drink the water because there can be fecal contaminants. So you can get Giardia and E. coli. So knowing that about us here in DC makes you think, should we be, are other places safe too? And so when you travel, it's nice to be able to have an app that will just tell you, what precautions ought I to take? Should I be buying, jugs of water here? So we collect data, and it'll tell you down to the water system level. So think around the size of a zip code, and it aggregates it into different topics. So it's a very complicated API with lots of really detailed data with not very good documentation. So we tried to make it really easy in the app. So what it's going to do is categorize everything into 5 categories and then tell you what you need to do. So if there's a biological hazard, it'll tell you, boil your water or add iodine tablets. Right. If it's chlorine, then a Brita filter might be enough. But if it's lead, Brita filters and pure filters and Culligans, they're not enough. They don't actually filter out lead. There is a pitcher filter that does. It's the only one in its class, the zero water filter. Or you can get a heavier duty filter. The solid carbon blocks can pull out lead in ways that the particulates can't. So we wanted to present this information. If there are carcinogens, or if there are the scary one, there's radioactive water. So just don't touch that one. There are things that can pull out sometimes for radioactivity, but still, If you're traveling, you're probably not gonna. Or if you live there, you're gonna wanna. Yeah.
So the app, oh shit. The app looks like this, and it. Can you hear me? Yeah, and it. We hard-coded a location in because when we first started doing it, we didn't have any database location for stuff near us. Now, when you hit this, it queries the DynamoDB NoSQL database, and it brings in points into the main activity. However, unfortunately, it places the markers underneath the marker that's already there, so I can't click on it and show you the next step. But yeah.
But what it does, and we can. Do you have the image on your? Yeah. So while he pulls that up, I can describe it. There are basically tables of strings that go from the code in the database to telling you what you need to do. So it's pretty much what I described. Just a little window pops up, and it also links to a test kit that you can buy. And there are 8 tests that you can perform in your own home or around where you live, and then we feed that data into the app. So we give instructions within the app, and then it feeds directly into our database. So for things like Giardia, it's probably going to affect the whole water area, the water system. But for things like lead, that's really on the street level. So it's nice to know, whether what your neighbors have said.
Yeah, cool. Thank you guys. If I could just get your names again and then your project name.
Claudia Perez.
Layla Wahidi.
Robert Rose.
Robert Cranen. And
we are Wellness Spring.
Yeah, thank you guys. Yeah, thank you guys. Great project. They're getting stuck. They're getting stuck. I'm gonna go there. There. We're going this way. Okay.
We don't keep a history.
Oh. Hey guys. Hey, I'm going around asking people what they did over the weekend. If I could interview you guys. If I could get your name, your major, and your school.
So, I'm Henry, biophysics at Johns Hopkins.
I'm Juliasco. I'm also a biophysics student.
We're all biophysics. I'm Max.
I'm Mariusz.
And then could I get your project name and the presentation?
Dozenth and one. Woo. Okay, so our project is called Tip of the Tongue. Okay, so I don't know if you ever have this problem. This is something that happens to me all the time where I'm trying to think of a word, only I can't think of that word. I think of like 5 other words that mean almost exactly the same thing. It sort of like blocks out my memory for thinking of that word. So we built a tool to help a person out in a situation like that. So unlike a traditional thesaurus where you can only search with one word, our tool you can search with many words, as many as you like. So say you're trying to think of the word sanguine, which is like a somewhat complicated word for like optimistic or hopeful. So that pops right up as like the top result for our search. So this is like a search based on a traditional thesaurus. We have other sources of information as well. You can get from an image search on Giphy, and it's basically by leaving Urban Dictionary off as the default option. That's like our safe search. What we found is whatever you search on Urban Dictionary, somewhere in the top 10 will be the word sex, like no matter what.
Okay, yeah, that's fair.
Yeah. Sometimes nastier words too.
Yeah.
So like.
12-year-olds rule the internet.
Yeah. But it's interesting how different like the stuff you get from Urban Dictionary is from like a traditional thesaurus. It's like more vernacular, and it's like the connections between the words are different. Yeah, try it out. And there's a mobile version too.
Do they have to be real words?
They have to be spelled correctly.
You'll get some error if not a really bad error.
Although if you put Urban Dictionary on it, it takes a lot of proper names too. You can search for Damon, for example.
Cut because of hack like that. Okay, cool.
Scotch. I don't know how I got scotch.
No, but I can definitely see.
Well, when you stop hacking, you gotta have some scotch.
Yeah.
There's always interesting.
Yeah, some of the stuff that the thesaurus brings up is real, like for happy, you get the word fit a lot. Whenever you search for it. I think it's like 19th century slang or something. I don't quite get it.
Okay, cool. Since I really like your UI, what kind of architecture do you?
So this is 1,200 lines of Python on the back end, and then Django for the front end.
And it's running on Amazon Web Servers.
We got
It's running on Amazon Web Servers. So it's because we have Bootstrap. It's also available on the mobile. It should scale fairly well. QR codes. Yeah. I don't know. Jelly can probably tell more.
Yeah, there's the mobile version.
I think that's a good summary. All right, that's really cool. If I could get your name again and then your project name.
Henry and
Juliasco.
Max.
And Mariusz. Tip of the tongue.
Cool, thanks. Let's go back down there. What's up? No?
It's just don't touch it. That just makes it worse. Just give it like 30 seconds and just keep on. Just keep on.
Hey guys. I'm going around asking people about the presentations over the weekend. My name is Christian. If I could get your name, your major, and your school.
My name is Adam Lee, and I'm a first-year BME PhD student and in school of medicine, I guess.
I'm Daniel. I'm a computer science and economics student at University of Maryland.
Oh, I'm Richard. I'm a BME computer science major at Johns Hopkins.
Cool. And then could I get your project name and the presentation?
Oh yeah. So we can present. Oh yeah. So, I'm Richard, and our project was called the Clinical Search Index. So clinical trials are basically research studies done to find new medications within healthcare and represent they represent the breakthroughs that will improve our health within the next 5 to 10 years in the future. So despite the wealth of data of clinical trials, there's a lack of ease and oversight in terms of finding successful clinical trials, which is a detriment for patients and researchers to want to know more about the successful clinical trials going on for a disease. So this is a high chart graph that we made. So here the x-axis represents sponsors, and the y-axis represents the frequency of completed clinical trials. So as you can see, so suppose you're a patient and you want to find a clinical trial about heart attacks, right? So if you just go within the literature, right? For all the completed publications that are actually finished, there's a very low percentage that have actual meaningful results, which means that if you wanted to know more about, heart attacks, you're going to have to weed through a lot of different, pages to find the clinical trial that has the results for you.
So to solve this problem, pretty much we are looking to provide the user with, a couple of solutions. And so one is just giving the user, and whether it's a patient or a researcher, the ability to search and provide better search functionality than Google or clinicaltrials.gov. And then second is just to visualize the data in a way that's helpful for them to understand what's there. And so, why is this so big? Why is it all the way zoomed up? Oh, okay, yeah. So one of the first visualizations you might want to look at is just, a heat map of the United States. And so this shows a heat map, and where green represents a low number of clinical trials ongoing, and red represents a high number of clinical trials. And so a caveat of this is just that we didn't have the resources to pull the entire clinical trials database from online, and because we had a lot of data mining and data processing, we didn't have the computing power. But we did a random sampling across the United States, and so it just happened to be that Wyoming had the most number of clinical trials ongoing. No, it's just a number of clinical trials ongoing.
Why would this be useful?
So this would be useful just to get a general overview of the clinical trial space. This might be useful for a researcher, but we have functionality that we'll show you in a bit that's useful for a patient. And so just going to the map a little bit more, what you can do is you can click on a state, and it'll show you a link to completed trials as well as ongoing trials, and it'll just show you a table of a list of information that we'll show you in just a bit. This is for all clinical trials. And then we also have a contact form that will link to that patients that are interested in enrolling in a clinical trial can fill out their contact information as well as disease areas that they're interested in partaking. And this links to a database in the back end that we can basically provide organizations their contact information so that they can continue talking. To make sure you're not a bot. And so to go into the actual search app.
So what our app does is basically it allows users to search for clinical trials based on a couple of features. And we have here the disease, the sponsor, and the state. And we also need to guarantee that the patient, or if a user is actually trying to participate in a clinical trial, that they are eligible. And there's some requirements that you need to fulfill, like, for example, gender, health, and age. All right. And so let's just dive right in. Okay. So for disease, we can do something like cancer. And I don't know the name of the sponsor off the top of my head, so we'll go to age. And let's say 25. And if you...
So you can leave stuff out.
Yeah, you can leave... Everything's optional. Cool. So you can basically... You can get everything if you just leave everything
Okay.
out. Yeah. So basically you get a heat map like you saw before, but this time it's specific to cancer. And like before, Wyoming has a lot of trials. So we click on this, we can take a look at the ongoing trials, which is probably what we're most interested in. And before that, if you want to...
Yeah, so just before that, we'll show you what clinicaltrials.gov sort of looks like. And so this is an example of a web page for a certain clinical trial that's recruiting right now. And so they have all this information, right? And this is all scientific information, and that's very important maybe for a researcher and scientists, but hard for a patient to understand. And so we wanted to provide patients with the best information that's relevant to them.
A little bit more user-friendly as well. So if we go to the ongoing trials, we'll actually show you a table of important information about the ongoing trials in Wyoming. And it'll have information like the sponsor, a link to the clinicaltrials.gov website, the actual condition, like kidney cancer, and the treatment that they're providing. But most importantly, we think is we provide a ranking for the sponsor. That's something we came up with ourselves, and it's to determine their credibility. And we base this ranking on the number of completed trials the sponsor had done, the number of publications that came out of these completed trials, and the number of current ongoing trials. And we think these are important because the more publications you have, the more probably successful trials that you conducted. Because pharmaceuticals aren't going to spend time and money publishing papers, basically proving themselves wrong. And so you can actually sort this table by the rank, which is useful. And you can see that the Alliance for Clinical Trials in Oncology is actually our top sponsor.
Cool. I guess, really quickly, I guess what separates our application from other applications is that if you go, let's say you went on Google search, right, and you looked up clinical trials for heart attacks, what you'll get is, while you'll get a very extensive list of clinical trials, these queries aren't optimized over I guess your parameters such as age, gender, or health status, which is important in deciding the eligibility for most of these clinical trials. And in fact, once you do find that you're eligible for one clinical trial, it might turn out that the sponsor has a, I guess, very poor reputation in terms of publishing all of their results, which means that they have a very low success rate in terms of publishing clinical trials. So yeah.
Thank you. If I could get your name one more time and then your team name.
My name's Adam.
My name's Daniel.
My name is Richard, and we're clinic.
We're CSI.
Okay, thank you. Yeah, thank you.
Shiv. I also go to the University of Richmond. We're all sophomores. And I'm majoring in math and computer science as well.
Okay. Like, how far back? Cool. Hey, my name is Christian, and I'm here asking people about their presentations. If I could get your name, your major, and your school.
Hey, my name is Ortega. I'm a mathematics and computer science major, a sophomore from Lincoln University in Pennsylvania.
Hi, I'm Michael from the University of Richmond, and I am a computer science major.
My name is Shiv. I'm from University of Richmond, and I'm a Math CS major.
My name is actually Shiv, and I'm from the University of Richmond, majoring in Math CS, and he's Alex. Yeah, we all sophomores.
Could I get your project name and what you guys did?
Sure. So we made a project called Open Tracker, and what the Open Tracker aims to do is to track the Zika virus wherever it is at a very granular level. So most of the time, if you see any sort of data relating to Zika, because it's so new, it's mostly on a country-by-country basis. All the CDC or the World Health Organization can say is, well, we know it's in this country. So we wanted to put this onto the people so that they could report where it actually is at a very, very granular level. So you can see our main interface is an interactive map with a heat wave showing all the Zika over time. And as well, we're also plotting with the purple pluses, we're plotting anywhere where people could get medical assistance. So these would be hospitals or also temporary medical camps. And the blue dots on the map represent areas of stagnant water that could be breeding mosquitoes, which of course carry the Zika virus.
So yeah, to show you guys, we have a feature to report a problem here, where essentially we've integrated Google Maps into our application, and when it gives you your current geolocation coordinates, and if they're not correct by any chance, you can move around the crosshair to get your actual coordinates. We've also added a little safety feature in our app to make sure that users don't spam our app. So if you report the same problem within a 2-mile radius, within a period of 24 hours, our app won't allow you to add the same coordinate in. So that was a little safety feature. At the bottom here, you can add the particular incidence or case. So we give you 3 options. We give you an incidence of Zika, we give you a stagnant water body, and we give you a standing water option. So yeah, that's how you add a problem to our app. So now, our main motivation is to give a governmental organization coordinates about an incidence of Zika, right? So what we made use of is a really cool clustering algorithm called dbScan. So what dbScan does is it incorporates a machine learning algorithm of its own. And let's say you have a cluster of coordinates, just like I've shown here. So within this cluster of coordinates, we want to give a governmental organization only a single set of coordinates to deploy medical resources to, right? So the dbScan algorithm gets a single coordinate within that cluster. And what we do is we've hooked it up to the Twitter API. So basically you can tweet the coordinates to a Twitter handle of a medical organization. For right now, we're only tweeting ourselves because we don't want to alert the CDC about... sorry?
Nothing.
Yeah, but yeah. So it says there's a problem at this set of coordinates. Alex will tell you a bit more about why we think crowdsourcing our data is going to help and why it's going to actually work.
So the main idea is that by helping yourself, you're actually helping society. So if you report on like Zika cases or standing water ponds, this effect will actually help you instead. But mic up. So our main idea is that by helping yourself, you actually help the society, because if you report on Zika cases and standing water ponds, this will in turn affect you in a good way.
So it's all essentially about marginal social benefit. If you live in a crowded neighborhood in a city like Sao Paulo, and maybe medical organizations are understaffed and they can't attend to every person who has Zika or every stagnant body, what we're providing is a way to actually get data on the location of all of these incidents. And let's say you're living in a neighborhood which has pregnant women, and I mean, what's the motivation for a user to take out time from their precious day to input this set of coordinates, right? it's not only to help these pregnant women and your neighbors, it's also to help you because the Zika virus is carried by mosquitoes. And if you're getting the government to tend to a water body that's breeding mosquito larvae, you're not only helping those people, you're helping yourself as well. So we really think that this is going to catch on. To tell you a little bit about our, yep.
All right, cool. If I could get your name and your school, that'd be your name and your project name. That'd be awesome.
Our project name is Open Tracker, and my name is Shiv.
My name is Alex.
Michael. Ortega.
All right, cool. Thank you guys.
Thank you so much.
Yeah, I loved hearing your name twice. Hello. This is a great name. All right, so my name is Christian. I'm going around asking people what they did over the weekend. If I could get your name, your school, and your major, and a quick overview of what you guys did.
So, my name is Kevin, and I'm here at Hopkins locally, and our app is this bathroom finder, and we'll hear more about it. Sorry.
No, you're fine.
Hello, my name is Andre. I'm from UMBC, and I'm a computer science major.
My name is Sam. I'm from Rutgers University. I'm an engineering major.
Cool. And then, what is your project?
All right, so first of all, there's a small, quick presentation, which is, do you want to pee? How about now? So you're in luck. You're a friendly neighborhood toilet locator. And what we have is a working model on the Android device, which essentially allows you to find the nearest toilet to you. So when you click near me, it accesses your location through the Google API. Okay. And then on top of that, it overlays another public API that we found called Anemone Maps, which shows the closest toilet to you.
The closest toilet to me is a mile.
Is quite a bit more than just a mile. So in order to compensate for that issue, we added another feature into our app, which was Add New. So when you click that, you add the current coordinates that you are at into the system. So now you can see in near me, there's a yellow marker where there's a new bathroom.
Right on top of us.
Crowdsourcing.
So in addition to that, when you use the bathroom, you tend to still stay on the phone no matter what.
Yeah.
So to compensate for that as well, we added a nice little game into our app so that you can just stay in our app the whole time. And the premise of this game is you have your stream, and you're trying to hit as many bowls as possible. And it is called Don't Stop Believing.
Okay, thank you so much.
No problem.
Okay, yeah, this is a fun game. All right, thank you guys. If I could get your name and your project name again.
Kevin.
Andre.
And Sam.
And your project name?
You're in luck.
Thank you. This is fun. I like this project. Okay, so we're gonna go up here. Sorry. Hey guys, did you guys do a project? Yeah. So my name is Christian. I'm going around asking people what you did over the weekend. If I could get your name, your major, and your school.
Of course. I'm Jackie Papo. I go to Hopkins. I'm a Chem B and a CS minor.
My name is Ertuğrul Alemdar. I'm also a Hopkins junior. I'm a Chem B and CS minor.
Hi, I'm Burhan Çiğdemoğlu. I'm a BME CS double major and a Hopkins junior.
Cool. And then could I get your project name and what you're doing?
Sure. We are MedVisor. So we created a web platform that could be accessed by doctors and patients by 2 different logins. We tried to address the problem of when a patient goes to their general practitioner, let's say they present with a set of symptoms, and the general practitioner oftentimes is not able to do anything but redirect that patient to a specialist. So we try to get rid of that intermediary step and direct the patient directly to the specialist that would be recommended by the doctors who are using this web platform.
So I can do a quick demo of our project. Let's say I'm a patient and I'm logging in right now. We used Google App Engine to develop our project, so we can sign in with our Google accounts. Normally, this medical data would not be safe with just a Google login, and we're aware of that. For the sake of proof of concept, we chose this project. So I have complaints here. that I've written in the past, and if I click on my complaint, I can see the departments in the hospitals that the doctors have redirected me to. And with this information, I can get the opinions of many doctors through a single platform within a very small amount of time. Normally.
Just to clarify, maybe. Just to clarify, in this chart, we're seeing how many doctors redirected this specific person with this specific complaint to these departments. So one here represents this complaint was redirected to neonatal unit by one of the doctors. And we also have a doctor interface for it, where the doctors can see the complaints and pick a department to redirect the patient to. Yeah, and this is how they log in.
In reality, of course, the doctors would have to provide their medical license IDs, which would be confirmed by a backend security protocol. Of course, we couldn't implement that since we don't have access to that kind of information.
So the doctor has access to a database of departments, and he can choose from the departments. He's also not allowed to type anything outside the borders. So I submitted general surgeon, and if I go inside, I can see that the general surgeon has increased by 1. Many doctors giving this input to a single complaint will also teach the doctors how the other doctors treat that same situation in terms of case studying. And also, we also thought about medical students accessing this database to see how the doctors regard the situations for the complaints. And this is basically our project.
Cool, thank you. If I could get your name again and then your project name?
So my name is Burhan Çiğdemoglu, and our project name is MedVisor.
My name is Ertuğrul Alemdar, and I'm a junior at Hopkins. My project name is MedVisor.
Yeah, and I'm Jackie Papo, also a KMBE, and here's the project. Yeah. Thank you.
Kind of sleep deprived.
No, yeah, no, I get it. Okay, cool. Thank you. See you later. Hope you guys do well. Okay, we're going around. Going all. Dun 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 dun. Dun. That. Sorry, I'm getting confused. So we're going over there. Cool. There's a lot more light in this room than other rooms. Okay. We're going up the stairs, careful. Hello. Yeah, we're looking at more than like 30 teams, 30, 40 teams. That's a lot. Hey.
Sorry, we're kind of busy right now.
Okay, sure, no problem. We've got them, but they are far. Can we go over there?
I will go here, you will go there.
Can't.
No, we can't. No, we can't.
We're done? Okay, cool. All right. Hi, my name Signing off. My name is Christian. This is HopHacks 2016. Really cool projects.